On tonight's homework, we're doing some problem solving by finding composite areas. Composite areas are areas that are composed of more than one shape. So when you look at problem number 2, you see that this bottom part of the shape is a semicircle, one half of a circle. But when you look at the top part, you've got some different options. I mean, you can tell just by the dashed lines you see a square and then a triangle, and you could certainly solve it that way, but you can also save yourself some time and realize, let me try to outline this thing and show you what I mean. If you realize that this whole shape above the half circle, above the semicircle, is itself a shape that we've already worked with. This whole shape is just a trapezoid, so you can just find the area of the trapezoid and the area of the half circle and add them together. So that's what we're going to do. We're going to find, I'll call this, make sure you can see this. We'll call this area A, and we'll call the trapezoid area B. And so, get a better color here. Area A is just a half circle, so we know a circle is pi r squared, so I'm just going to do 1/2 pi r squared to find the area of this semicircular region at the bottom. Area B is a trapezoid, and the formula for area of a trapezoid is 1/2 multiplied by the sum of the bases, b1 plus b2, multiplied by the height. Now we have to look for our dimensions. Well, I don't want to do too much of this. I want you to sort of take it from here. This is the main idea. We'll go over the details after the pause. But if you can find the dimensions, keeping in mind that every time you see one of these hash marks, these marks of congruence, it tells you that the line segments are congruent. So that's how I knew this was a square, just by glancing at it. All 4 of these line segments are congruent, and I also know that this line segment is congruent to this line segment, and each of these is just half of this distance, right? This 16-meter distance. The 16-meter distance is going across the circle and through the center, so it's the diameter, so you're going to have to take half of that to get your radius. So try to get the dimensions you need for these formulas and then substitute them in during the pause. You'll be adding area A plus area B to find the area of the whole figure. Do that during the pause. Come back and see how you did.
Paused.
Okay, we said before the pause that this 16 meters is the diameter, so the radius is 8. So the area of region A, which is the semicircle, is I'm just checking to see that the directions do tell you to use 3.14 for pi, so it's approximately 1/2 of 3.14 multiplied by the radius is the half of the 16, so 8 squared. Simplifying this, I'm going to do the exponent first, of course. 8 squared means 8 times 8, so that's 64. So I have half of 3.14 multiplied by 64. And then I'm going to associate to my advantage. I'm going to multiply 1/2 times 64, since 64 is an even number. And that's 32, so the area of region A is approximately 3.14 multiplied by 32. We can do that on the side here. 4 3s is 12, carry the 1. 1 3 is 3 plus 1 is 4. 3 3s are 9. So I get 8, 4, 10, carry the 1, 10. And then I have hundredths multiplied by wholes. So 2 decimal places and no decimal places. That should give me 2 decimal places in my product, so 100.48. For the trapezoid, area of region B, we have 1/2 multiplied by base 1 is just, remember for a trapezoid, the bases are just the parallel sides. So this is a base and this is a base. This bottom base is 16, and this top base is equal to the radius of the circle, so it's 8. So 16 plus 8 multiplied by the height of the trapezoid is the perpendicular distance between the bases, which is also 8. So I have area of region B is equal to half of 16 plus 8 is 24, multiplied by 8, half of 24 is 12, and 12 multiplied by 8 is 96. So the area of shape B is 96. The total area is going to be equal to area A plus area B. So 100.48 plus 96, that's easy enough, just 196.48. Did it ask us to round in a specific way? It did not, so I'm just going to leave it as, oh no, it does say round to the nearest tenth, so I have a 4 in the tenths place. The digit to the right in the hundredths place is 5 or more, so I'm going to round that 4 up to a 5, so 196 and 5 tenths. The units will be, our units are given in meters, so since it's area, it's meters squared. Area is 2-dimensional. The amount of 2-dimensional space being taken up by the shape. Okay, just real quick before we end this, if you look at problem 1, you see a half circle and a triangle, so very similar to this problem. If you look at problem 3, there are many ways to break that shape up into pieces. I think the easiest way, if you draw a line in the right place, you can get a trapezoid and a rectangle. The two problems on the back, 4 and 5, those are area subtraction problems. So, for example, problem 4, you could clearly see a triangle, but the shaded region doesn't include that square hole in the middle. So you find the area of the triangle, you find the area of the square, and you subtract the area of the square from the area of the triangle. And there's something similar going on with number 5. You have a hole, a circular hole in a parallelogram. Okay, I hope that helped. I'll see you tomorrow.